Our main topic is applications of differentiation. So, what is differentiation? Differentiation is a technique of determining a function's derivative or rate of change. The rate of function is defined as dy over dx equal to fx equal to y. Differentiation can be used to detect if a function is increasing or decreasing. In this topic, we will learn about related rates, analysis of functions 1, analysis of functions 2, applied maximum and minimum problems, Rolle's theorem and mean value theorems. In this video, we will focus to analysis of functions 2. A function is defined as a relationship between one variable, the independent variable, and another variable, the dependent variable, is defined by an expression, rule, or law. In analysis of function 2, we will know about two graphs. First, graph of polynomial functions. Second, graph of rational functions. Analysis of functions 2 frequently dives into more sophisticated calculus topics and methodologies. Limits, continuity, derivatives, integrals, and their applications are all covered. Understanding these principles is critical for future study in mathematics, engineering, physics, and other professions that rely heavily on calculus.
Problem statement for polynomial, we have given a function fx equal to 2 minus x multiplied by x minus 5 squared. We have to find the x and y intercept of x, then the critical point of f, then the intervals where f is increasing or decreasing, hence determines the relative extremum of f, if any. Then we have to find the intervals where f is concave up and concave down. Hence, we need to determine the inflection point and sketch the graph.
For question A, we need to find x-intercept and y-intercept. For x-intercept, if we want to find x-intercept, we need to make y is equal to 0. So, the equation will be 0 equal to 2 minus x multiplied by x minus 5 squared. And you just need to solve in order to find x. So, it will be like 2 minus x equal to 0 and x is equal to 2, and the other one is x minus 5 equal to 0 and x equal to 5. For y-intercept, the x is equal to 0, so you just need to substitute 0 into the equation, and it will be f0 equal to 2 minus 0 multiplied by 0 minus 5 squared, and the answer is 50. For question B, we need to find the interval where fx is increasing and decreasing. Hence, determine the relative extremum of fx, if any. For this question, it has 5 steps in order to solve this question. For step 1, we need to find the derivative, which is f prime x. In order to find f prime x, we need to simplify the equation that we have, which is 2 minus x multiplied by x minus 5 squared. And when we simplify it, it will be negative x cubed plus 12x squared minus 45x plus 50. When we have that equation, we just need to differentiate it, and it will be negative 3x squared plus 24x minus 45. For step 2, we need to let f prime x equal to 0. After we equal it to 0, we just need to factorize it and find x. So it will be x minus 5 equal to 0, and x is 5. The other one is x minus 3 equal to 0, and x is 3. For step 3, we need to make a critical line. To make this line, you just need to make a single line and put the value which is 3 and 5 that we just found in step 2. We make this critical line so that it's easier for us to make the derivative first derivative table, which is in step 4. In derivative table, it contains interval, test value, and sign of f prime x. For interval 1, we put negative infinity and 3. For the second interval is 3 and 5, and the third interval is 5 and infinity. For the test value for interval negative infinity and 3, we put 0, which is you can just choose any number that you want with the number from negative infinity to 3. The second test value is 4, and the third test value is 10. Okay, for the sign of f prime x equal to negative 3x squared plus 24x minus 45, you just need to put the test value into the x and calculate it and find if it's negative or negative, and you just put it in table. But the symbol and it don't have to be same symbol. For example, if the first one is positive, second one is negative, and the third one is positive, it can't be like positive, positive, positive. It has to be like positive, negative, and positive, or negative, positive, negative. Okay, after that, you can find the increasing interval, which is 3 and 5, and decreasing interval, negative infinity and 3, and 5 infinity. For step 5, we have to determine the extremum point. In this part, we just need to substitute the value, which is 3 and 5, into the equation. For the first one is f3 equal to 2 minus 3 multiplied by 3 minus 5 squared, and the answer is negative 4. For the other one is f5 equal to 2 minus 5 multiplied by 5 minus 5 squared, and the answer is 0. And after that, we can find the minimum point and maximum point, which is minimum point 3, negative 4, and the maximum point is 5, 0.
For the next question, which is we have to find the intervals where f is concave up or concave down and determine the inflection point. So we need to differentiate the fx twice to get the f double prime x, and we will get negative 6x plus 24. So this next steps is from the f double prime x, we will we will find the value of x, and we will do negative 6x plus 24 equal to 0 to find the value of x. So we will get x equal to 4. Then we have to do the inflection line as shown below. Then for the step 4, we have to do the second derivative table, which have interval, test value, and sign of fx and sign of f double prime x. For the interval, we have to look at the inflection line and do the interval which is negative infinity until 4, and the second interval is 4 until positive infinity. For the test value, we have to choose the value between the interval, which is the value between negative infinity until 4 and the value between 4 until positive infinity. Then substitute the value at the f double prime x equations, which we will get positive and negative. The positive will be the concave up, and the negative will be the concave down. Concave up, we get negative infinity until 4, and the concave down, 4 until positive infinity. Step 5, we have to determine the inflection point. So we will use the value of x that we got, which is x equal to 4, and substitute into the fx equation. So we will get negative 2. So the inflection point will be for negative 2. 4 is the f double prime x equations that the value of x that we got from the f double prime x equations, and negative 2 is what we got when we substitute the value of x into the fx equation. So the inflection point is for negative 2. For problem statement for rational function, we have given a function fx equal to x divided by x plus 6. We need to find the y-intercept and x-intercept of the given function and find the vertical and horizontal asymptotes. For this part, we need to do the analysis of the horizontal and vertical asymptotes. Then we need to find the intervals where the function is decreasing or increasing. Then determine the inflection point, and we need to sketch the graph.
For the first step, we need to find x-intercept. So, how we can find the x-intercept? First, we have to make y equal to 0, then we will get the answer. For y-intercept, we need to add 0 in the value of x. Then, we will get y equal to 0. Find the vertical and horizontal asymptote. First, in order to find vertical asymptote, we will let the denominator equal to 0. Then we will get x as x equal to negative 6. Next, we will try to find the analysis for the limits. Let's say when x approaches negative 6 from left hand side, the function is x over x plus 6. We have to make a real number line here where the interval is negative 6, and we have to take a value that very close to negative 6 from left hand side, which is negative 6.001. Then we substitute the value of x, then we get positive infinity. Same as the second, let's say when x approaches negative 6 from right hand side, we need to find a very close value to negative 6 from right hand side, which is negative 5.999, and then we try to substitute the value, then we will get negative infinity. Next, we will look at horizontal asymptote. For horizontal asymptote, we will find the limit for fx when x approaches positive and negative infinity. For the solution, we need to use cube method, which is we need to divide all the numerator and denominator with the highest degree of x in denominator. Then we will get the horizontal asymptote y equal to 1. C. For this question, we need to determine whether the function is increasing or decreasing. So we need to find the first derivative. So since our fx is equal to x over x plus 6, we will use quotient rule. F prime x equal to v u prime minus u b prime over b square. We need to substitute the value here in the quotient rule. Then we need to expand the value, and we got 6 over x plus 6 square. Next step, we will find the extremum point. We need to let f prime x is equal to 0. In this case, we have 6 over x plus 6 square is equal to 0. So, for the numerator is 6, and then the denominator is x plus 6 square. We just focus on the denominator, so x plus 6 square equal to 0. Then we get extremum point as negative 6. Next, we will make critical line. And since we have only one value, we need to interval. So the first interval is from negative infinity to negative 6, and second interval is negative 6 to positive infinity. Then we should draw a table. For test value, we can use negative 7 and 1.
we need to substitute the value into the function, and we can see here from the table we only have positive signs, which means that the interval increased from negative infinity to negative 6 and negative 6 until infinity, and there is no decreasing, hence there is no extreme point.
Next, we have to find the intervals where the function concaves upward or downward. Next, we have to differentiate f prime x equal to 6 over in bracket x plus 6 power of 2. Before we differentiate f prime x, it's easy for us to move the denominator to go up to be 6 in bracket x plus 6 in power of negative 2. Next, we can differentiate f prime x using chain rule, and we will get negative 12 in bracket x plus 6 power of negative 3, and we can change it to be in normal way, which is negative 12 over in bracket x plus 6 in power of 3. So basically for negative 12 equal to 0, there's no solution for x, but for the denominator in bracket x plus 6 power of 3 equal to 0, we will get x equals to negative 6. So we will transfer all the information into the table to know the concave. For the interval, we put negative infinity, negative 6, and negative 6, positive infinity. And for the test value, we take negative 7 and 1, and sign of f double prime x, we get positive for the test value of negative 7, and we get negative for test value of 1. So for the conclusion, the positive will get concave up, and for the negative we will get concave down. Therefore, interval of concave up is negative infinity, negative 6, and interval for concave down is negative 6, positive infinity. Lastly, we can determine the inflection points by substitute negative 6 into fx equal to x over x plus 6. So we will get negative 6 over 0, which is it is undefined. So there is no inflection point because fx is at x equal to negative 6. Next, we will sketch the graph of fx using information obtained from A to D. So first, what you have to do to sketch the graph is to draw for vertical asymptotes, which is x equals to negative 6, and you have to draw for horizontal asymptotes, which is y equals to 1. And we will use all the information that we get from A to D to draw the graph, and we will get this kind of graph for this question.
We can conclude that there are two types of graph in analysis of function. The first one is polynomial graph. The graph of polynomial function will touch the x-axis at 0, and the graph will continuous. Also, we can find the maximum and minimum point, which is the extreme point at first derivative, and we can determine the concavity of a function by looking at second derivative of f. The value that we found in minimum point is 3, negative 4, while the maximum point is 5, 0, and the inflection point is 4, negative 2. Next is rotational graph. There are a difference between rotational graph and polynomial graph. To sketch next is rotational graph. Rotational graph are a bit different than polynomial graph. To sketch a graph of rotational function, we can find it using the asymptote. An asymptote is a straight line that a graph approaches without touching, and the rotational function also the rational function of graph also will be discontinuous. And from the question, we have vertical asymptote x equal to -6, horizontal asymptote y equal to 1. And in this, in rotational graph, there is no inflection point because fx is at x -6. And there also no extreme point because there is no interval of decrease.